So hi everyone, today we are going to start the class with the concept of acceleration due to gravity. So what do you mean by acceleration? Acceleration is actually the change in velocity with respect to time, and it is represented by A. It is equals to the change in velocity, that means v minus u divided by of t. This thing we have already learned in the previous chapter, that is motion, right? But in this chapter, we'll learn that the acceleration that will be produced due to the gravity. Now, what is gravity? In the last class, we have already discussed that. Now, suppose this is our Earth surface and there is an object like that. So, this is the object, it is having a mass of m, and this is the center of our Earth. So every object on our Earth's surface is attracted towards the center of our Earth by some force of attraction, and that force is known as force due to gravity, right? So whenever any object is falling from a particular height, suppose I'm just talking about this object, it is having a mass of m and it is placed initially at a height of h, and from this height it is made to fall in this direction. So obviously whenever it will be falling, so the acceleration of that particular object should be only due to the gravity, because this is the one type of vertical motion of the object. It's not a linear motion, right? So whatever the acceleration will be produced in throwing the object upward direction or in the downward direction, that should be only due to the gravity, right? What is gravity? Again, I am repeating. That means it is a force by which the object is attracted towards the center of the earth, right? So in this case, this object, whenever it will be just falling down, so it will be attracted by the center of our earth. That's why it is falling. So the acceleration due to gravity is represented as small g. Okay. Now the value of the gravitational acceleration is maximum at the polar regions. Suppose this is our earth, okay, and this is the polar regions. So at this point, whenever any object is thrown in the upward direction or it is falling in the downward direction, in that case the value of g is maximum. And at the equator regions, as the distance of the equator region is greater than the polar region, we can say that the gravitational acceleration will have less value instead of the polar regions. Now there should have some question that why this acceleration at the polar regions is maximum, because the distance of the polar region from the center of our earth is minimum. That's why the gravitational acceleration is maximum. The force of attraction is maximum. But the equator region is at a greater distance from our center of earth. That's why the gravitational acceleration is less. Okay. Now let's find out the mathematical expression of this acceleration, that means the gravitational acceleration. So we know that whenever any object is falling down, if this is the object which is having a mass of m and it is falling down in this direction, right? So the object is falling because of its weight. Weight is a one kind of force that is acting on this object, and that's why it is falling. So according to Newton's third law, what we know, that the applied force is equals to the mass of the object multiplied by the acceleration, right? In this case, whenever the object is falling down or it is just going in the upward direction, the acceleration will only written as g, gravitational acceleration. And in this case, the product of mass and gravitational acceleration is the weight of the object. Okay. So by this expression, we can find out the weight of any object if the mass is provided to us. Okay. And according to the Newton's universal law of gravitation, we can say that the force acting between two objects, if this is our earth and this is the object which is placed on the earth surface, and the distance of that particular object from the center of earth is capital R. that is equals to the radius of Earth. So in this case, the force of attraction, that should be equals to gravitational constant multiplied by the mass of Earth multiplied by mass of the object divided by square of the radius, right? So we know according to the definition of weight that it is the one kind of force by which the object is attracted towards the center of Earth. So the force of attraction should have the value like that, and it is also equals to the weight of the object. So we can say the value that is of mass into gravitational acceleration and this one will be same, because this force of attraction is actually the weight. So we can say that F is actually equals to the W, and this capital G into capital M small m divided by of R square, it is equals to mass into gravitational acceleration. So whenever the M are getting cancelled out, I am getting the final expression of G, that is equals to capital G gravitational constant multiplied by mass of Earth divided by the radius of our Earth, that whole square. So in this case, the gravitational constant is having a value of 6.67 into 10 to the power minus 11 Newton meter square by kg square. The mass of Earth is how much? 6 into 10 to the power 24 kg, and the radius of Earth is 6400 kilometer. It is equals to 6.4 into 10 to the power 6 meter. We'll substitute these values in this expression. After substituting, I will get some value of gravitational acceleration. So let's substitute that values here. That small g is equals to g into m by f r square. G is having the value of 6.67 10 to the power minus 11. Mass is 6 into 10 to the power 24 divided by 6.4 into 10 to the power 6, that whole square. Now let me simplify that. I will calculate this powers at first. So I will write down 6.67 into 6 divided by 6.4, that whole square, multiplied by 10 to the power minus 11 into 10 to the power 24, and here it will be 6 to the 12, right? So in this case, this part you can calculate by yourself. 6.67 into 6 divided by 6.4 whole square, and it is, if 10 to the power 12 going upwards, it will be 10 to the power minus 11 minus 12, that means minus 23 into 10 to the power of 24, right? So how much we are getting after the calculation? Let me calculate. So after calculation, I am getting the value as 9.8 meter per second square. Now the value of this acceleration due to gravity on our Earth's surface is 9.8 meter per second square. The unit of acceleration is same for the linear as well as for the gravitational also, right? Now you can find out the value of gravitational acceleration at the moon, right? This is your homework. So the mass of the moon I have already provided in the previous class, though I am providing again. Mass of moon, it is of 7.36 into 10 to the power of 22 kg, and the radius of moon, it is of 1.76 into 10 to the power of 6 meter. Okay, all the values I have already provided. So you just find out the gravitational acceleration. The formula should be as g dash, or you can say g of moon. It is equals to capital G into m divided by of r square, but here at the suffix write down the word moon. Okay. The value of gravitational constant will be same. As you know, this is the universal gravitational constant, as it is not depending on any other values. After substitution, tell me the answer, what you get.